This is Møller Nielsen from Java Code Geeks, and I'm going to teach you how to write clean, efficient code using Terraform. If you have always wanted to administrate all of your cloud resources with one tool, then Terraform might be that tool for you. Now, complementary to this video, there will be related articles and links in the description below. Please take the time to like, subscribe and hit that notification bell because we have a lot of cool stuff coming up. Now, without any further ado, let's get started. So what is Terraform? Terraform is a tool that can handle and enable us to actually have infrastructure as code. And having infrastructure as code is a huge benefit because then we can have all of our code in Git, and then we can have version control on all of our resources actually, and we can actually have one tool that where there are plugins providers to each of the big clouds, and that is this means that we can use the same tool for all clouds and for all tools and for all frameworks that have created something called a provider for Terraform. Terraform has two products. It has its open source and free. It has a free version, a community edition, and then it also has a cloud version. In the cloud version, then we can actually execute our Terraform code in the cloud instead of executing it locally. In this video, I will explain to you how to execute code locally, but the principles are of course the same whether you execute your Terraform files, your Terraform projects locally or in the cloud. Okay, so first of all, there are some concepts we need to talk about. The most important concept is actually the Terraform provider, because this is where all the magic happens. So Terraform is actually a kind of a platform where different providers can create their own provider code and then make this accessible to everybody for everybody to use, and then everybody can use these providers, these plugins, and then they can execute actions or they can actually ask for states on the inside their clouds. Terraform works with where it's a definitive language, and you say what you want, and then the road to get to what you want, that is actually the job of the provider. So it's quite simple. You just say you want maybe a bucket, S3 bucket with this name, with this tags, and then Terraform will actually do all the magics, or will actually do all the small steps like checking is the bucket already there. Does it have all the right tag? Does it have all the tags, or maybe just two of the tags? Should we alter the bucket instead of destroying it and then recreating it? Or all those things are handled by Terraform, and of course most of these things can be tweaked and configured, especially for the bigger clouds. There are really good provider support for those. So this means we have this awesome language, this awesome platform, and then we have all of these thousands of providers where we can actually just search for in these providers, and then we can create resources in the cloud. So that is the whole point of Terraform. And it is very popular. So all of the big providers, as I said, they of course they support. They have created their own and they also maintain their own code for HashiCorp as a HashiCorp provider. So what we need to go through is actually we need to write some Terraform files. So this is kind of the development cycle. We will write some configuration files. We will write some Terraform state files, and then we run the Terraform plan, because everything is run through a CLI tool named Terraform, and most people actually create an alias TF for that points to the Terraform CLI. And there are some things that can be done with the Terraform client. Most of the things are actually just four things. One of the things is to initialize. This will download the providers that are mentioned inside the Terraform files. So then we will have the providers, all of the code locally. So that is the first step. The second step usually is to call Terraform plan. Then we will see a plan of what is going to happen if we choose to write Terraform apply. So the plan is it is actually a plan, as it also says, where we can see what is going to happen. Do we agree with this or not? And then, of course, we can change our configuration if this is not what we meant. Then we have apply. This is where it actually is being applied. This is where we actually are creating our resources in the cloud, or deleting or changing our cloud's name if that's what we want to change. So the apply, that is of course the dangerous step, and there's another step named destroy, which is of course also very. It's a bit dangerous because, of course, then we can actually remove all of our resources once again. And this is what I'm going to show from the beginning on how to actually get through this whole process. I'm going to use my use case is that I want to create an S3 bucket and I want to create a Google bucket. And credential-wise, Terraform by itself does not have any support for credentials. That support is being given by the provider. So this means that you actually have to read up on the documentation for each provider. So whenever you have a new provider, let's say that I want to add Asia also, then I would have to read up on the provider documentation, which is pretty good, right? It's very good in most cases. And then I would actually have to I would have to provide the credentials, of course, and I would also have to configure the provider so it actually works. Most of the cloud solutions have a region that we have to give, and they also have a project name. If we are talking about Google Cloud, then there's also a project name that we have to configure our provider with. So all in all, this actually means that we need to start with actually having access to a cloud, and I've gotten access to Google right here. So this is my Google Cloud, and I have one user that I've created for this purpose right here. I've created a new user named demo user, and then I have the credential JSON file, which is being created the first time when I created this user. Then I got this JSON file, which is my credentials. I then placed that. I'm running on WSL. This means Windows Subsystem for Linux. This means I'm actually running on an Ubuntu Linux instance. And that JSON file, I placed that inside the .google file, a folder where it should be placed. I'll show you this in just a minute. I just want to tell you that you need to have access, of course, to your cloud before you can run your Terraform scripts. I've already set this up, and of course, I will also show you how to set this up. It's just so you know how the magic actually works. So I have my Google Cloud right. This is actually my AWS cloud I have right here. So let us go to my Google Cloud right here. This is my Google Cloud that I have right here. And I have some projects. Actually, I only have one project right now. I have my Mike's demo project, and in a normal situation, you would have multiple projects, and that's why the project is one of the arguments that we need to configure our provider with. Let us go into this demo right here, into the Mike's demo, and then I'll go to. Then we'll look at the storage. It's called cloud storage. Those are right there, and here we have some buckets, and I already have one bucket right here. So let me just remove that. So this is Mike's file bucket. This is the bucket that I want to end up with in the end, and the location right here is EU, and the location type is multi-region per default. So this is the result that I want. Let us go and look at how to write this code right here, because first of all, of course, we need the tool. We need the Terraform tool, and we can download that. We download that from terraform.io. It's quite easy. You can download it for your operating system. I'm using the Linux, so I went to the Linux and then I followed this guide that was right here. It's actually quite easy. It's quite simple. It just installs. It's actually with apt install Terraform right there. Then it installs Terraform, so the Terraform could be accessed globally wherever you are on your Ubuntu instance. The same with Windows. You can just download and use it, and if you use a Mac OS, you can use brew to install Terraform with right there. So installation is quite easy. It is it's a two-liner for Mac OS, and for Linux it's a three-liner. So we can definitely not complain about that. After downloading and installing Terraform, then you can create a project. So you just create a folder somewhere. You just create a folder, and that folder that you would create is right here. The folder that you will create, you can have multiple providers and multiple things that should happen. You can in the same folder. But to make this a bit simpler, I've created two folders right here. I've created one folder where I want to do something with Google. This is my Google Cloud example, and then I have my main.tf file. You can name your .tf for Terraform, of course. You can name your .tf files whatever you want to name them, but it is a standard. It's kind of a convention that you at least have one main.tf file, and this is where the main this is where the main actions are located. The main resources are located. Those would be put in your main TF. So you should be able, as a developer, to open up main TF and then kind of get a feeling of what should happen in this module right here. Each folder is called a module, and you can have modules and you can have sub-modules that uses where the main module uses the sub-modules if you want to. Then we have a package.json file right here, and let me just the reason why I have that is because then I can just right click and then I can press run. This means that then I do not need to write so much in the console. So right now I actually start with running the Google delete, and this is of course this is just my name, my logical name that I've chosen, and what it's actually run is Terraform destroy. So now let us just go look at the cloud and see if my bucket was now deleted. So let us just refresh once we're here. So yeah, so now there's no rows right there. So my bucket has just been deleted. So this is where we define what actually should happen. That is the main.tf file. There's also another file you can see right here. That is my terraform.tf state. This keeps the state of all of my resources, and it always creates a backup right here. So this means right now there's no state. This means that I do not have my resource. And this also means that the Terraform it wants to keep track of the state that the resource is in right now, and this can actually give problems if you have some colleagues that are applying the same things that you are. Then your local version might not be synchronized with your colleague's version, and that is why the cloud version of HashiCorp Terraform can be a good idea. Or you could also place it, of course, on your CI system like Jenkins or Bamboo. There's also one possibility. I'm going to delete this just to begin with, so you can see how it all starts. So there's a folder named Terraform, hidden folder named Terraform right here. There's also a log that I'm going to delete. So to begin with, I just have my main.tf file, and then I have my package file. This is just because I'm lazy. I don't want to continue writing all of these things in the terminal. That's why I have this package.json file. And I've created this file by writing npm init, and then just enter, and then you end up with a package.json file where you can actually right-click and execute script from. And I'm using VS Code, and there is a very good extension named Terraform. It is right here, HashiCorp Terraform right here. It has only gotten 2.5 stars, I think. I don't understand why actually, but there are also other Terraform plugins. I have not tried the other ones. Maybe they give better code completion. Maybe that's why it has only got 2.5 stars. But as you can see right here, there are multiple Terraform plugins, and I've used the official one. This is the official one that I'm using right here. So let us go back. So to begin with, I only have these two files right here. And how did I get all the other files? The first thing that we want to do when we have a main, first of course we have to create our main.tf file. And how do we do that? Yeah, we have something called providers, and in this situation I want to integrate with the Google Cloud, so this means that I need to add these lines right here. This is not something that I have invented myself. This is something that you will actually look up, and then I am configuring my provider right here, and I'm setting the project. It's named Mike's Demo right here. And I'll show you where we actually find all of this information right here, because this is just something that we look up in a hash in the Terraform registry. That is where we can look up these lines right here, and we'll just copy paste them. So then we have the other lines right here. Those are found in the documentation for the provider. So this means after I've chosen that I want to play around with the Google Cloud, then I can actually look in the documentation for the Google Cloud provider, and then I can see that I can actually create a resource of the type Google Storage Bucket. So this is the type Google Storage Bucket. That's the first argument. The second argument, that is just something that I have made up right here. So this is This is just my logical name, and there is a naming standard. That is that you should always use underscores. You should not use dashes in the name. And you can also see that the types right here. If you don't type the right type, then you will actually get an error when you try to run, or when you try to plan your Terraform script. So I'll just name this Mike's Bucket on Google like this. And here then it has a name, and it has a location, and it then has some arguments. And again, these arguments here, these are the ones that we have to look up in the documentation. There's a force destroy true. This means that when we are destroying this bucket, then it will automatically destroy all of the files inside them. That is what this argument right here says. Then we have a lifecycle rule, and this was just to have some more stuff inside this file right here. This means H3 means that when files inside this bucket is 3 days old, then they will be deleted. So this is a temporary storage that we have right here, as you can see right here. That is what we are trying to set up right here. Okay, so let us before I run anything else, let me just show you where I find these lines right here, because they are. We go to registry terraform.io/providers. And then we can actually just search for stuff. And I've searched for Google Clouds in the search bar in the top, and then I can see how to use Google Cloud. And there's a button. There's a purple button in the top right corner. If I press Use Provider, then I get some lines of code. Can you recognize those? Yes, you can, of course. Those are the lines that we actually get. Those are lines that I have in my Terraform file. So that is the beginning of my Terraform file. Then I have defined that I want to use this provider, and then I have configured it with one piece of setting, which is project. I could also have given it a region, and then it is when you choose a provider, it's very important, of course, that you read at least the initial setup guide. And this is the initial setup guide for Google. There's a whole other guide for Amazon, and a whole other guide again for Asia. And this is what makes it very specific to the use case. Whenever you have a new cloud, you have to read up on how to use that provider. But it is quite easy. It is very, very easy, and it's not that much actual documentation that you have to read every time. And then it's usually also very good categorized. You can see here on the left side we actually have all of the resources from Google Cloud, and there's something called cloud storage somewhere. That is what I read to make this demonstration right here. So here's cloud storage. If you click that one right here, then we should be able to create a bucket, for instance. So this is how to create a bucket, and then we get the whole example right here. And this is where I've copy pasted most of this example from. So let us go back to my example right here. I have project Mike's demo. I have Terraform, the required providers. So how do we continue from now on? First of all, we need to get this provider. We need to get the plugin. We need to get the code. Or else, of course, it cannot execute all of the commands. So we actually get the resource on our clouds. And the way we get started, the way we download the provider, the plugin, is by writing Terraform inits in the console. Or if you're lazy like me, then you just right-click and say Run Script in your package.json file. This is actually an approach that I really like to use. That it does not matter what kind of language or programming language or whatever you're doing. You always need to execute some scripts, some shell scripts, and you can why not make a package.json file so all of your colleagues can actually enjoy the same features as you are, and then you can just right-click and then then you can execute and run the shell commands that you want to run. There are also some people, they also like to actually create .shell files, .sh files inside the project. I just think this is a bit better because here we get a good overview of what's going on, and it's quite easy to right-click, and we can also see them. There's an npm view where we can actually execute all of these scripts very easily by pressing a play button in both VS Code. And if you use another tool like, for instance, IntelliJ, then there's also a plugin for that. So now it has. The reason why I was talking so much was actually because there was a slight delay because it had to download the provider, and those providers, they can actually take up some space. It can be like hundreds of megabytes that is being downloaded and then being placed in here. This means that you need to mention in your .gitignore file that the .terraform folder should not be included into your Git commits, because then you would commit a binary, and you should never do that, of course. Git is good with source code, but it's quite bad with binaries, of course, and it just clogs up the whole system. So that now we have the Terraform file right there. Then it has created a log file. And now we can actually continue, because now we actually have the code that needs to be run. So this means that now we can run then we can run Terraform plan. So this is what I run now, Terraform plan. And then I can go look in the outputs and see what is actually going to happen right here. So it says right here, Terraform will perform the following actions. Okay. The Google Mike's buckets on Google will be created. Okay, thank you very much. Force destroy true. And then there's some, if there's a lot of fields that I have not set, and that is okay, because then there are some default values that would just be chosen. And then we have name, Mike's Mike file bucket, that is the name right now. And here we have some lifecycle rules that are set up that it should be deleted after 3 days. If the file is older than 3 days, that's good. Then it's just a temporary file storage that I have right here. And then it says you can now run the Terraform apply if you want to apply it. This line right here, we'll come back to that in the second example. Do not think too much about that. This just means that you cannot be totally sure that it is the exact same plan that will be run when you run Terraform apply, because I did not give this argument. Also, if you give this argument, then it would actually save the plan, and then when you write apply, then it will run exactly the same in the same way as it was actually planned. This means that if there was some variables, which we will look into the second example, if there was some variables that had changed in the meantime, then if you had saved your plan, then those new variables would not have been used. The old variables would have been used instead. So that is a cool thing about using the -out and then actually creating your whole plan into, saving your plan into a new file. So, but in this example right here, we actually just want to apply. So we just want to apply and see what then happens. I will right-click and run script right here. And then it says again here, this is what's going to happen. Yeah, of course we got the recap again. This is what's going to happen. Blah 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 blah. 1 to add, 0 to change, and 0 to destroy. I think this summary right here is quite good, especially if you have a lot of resources. Then you can see, suddenly if you see 2 to destroy when you are trying to apply, then you should try to see. Then you should, of course, try to go up and see where is the minus. Right now, there's a plus for all of the stuff that is being added, and then of course there's a minus for the resources that will be deleted if there was any resources to be deleted. Maybe you made an error in your script, so then suddenly there's something that was mentioned in an earlier version, but which is not mentioned anymore, and that is why it is actually destroyed. So always look at this summary right here. That's quite important. Usually, if it's just add, then no harm is done usually. Of course, of course you have to see what's actually going on if it should be changed. So now we have apply completed, resource 1 added, terminal reused. You can just close it. That's fine. Let us now go to our Google Cloud. So I'll go to my Google Cloud, which is right here, and then let's press refresh. Now I have one bucket right here. Okay, that's quite cool. I'm not happy with the name. And it also has a lifecycle rule right here, lifecycle rule. I'm not happy with the name. It says Mike file bucket. I would actually like the name demo inside it. What do? Let us just go back and see how can I change this quite easily. I can go to my main.tf file, and I can go find my resource. My resource is right here, Mike's bucket on Google, and then I can go down to the name property, and then I can say Mike's demo bucket, like this. Save it, and then I can see, first I'll run the plan to see what is going to happen now that I changed one property. It will actually, look what actually happens right here. It will actually add a new bucket. The reason why it will do that, is because with Google, you cannot just change the name of the bucket when it is actually created. This means that it has to destroy it first. So there's one to destroy, and then there's one to add. So this all depends on the resource that you're dealing with. Some cloud resources can just be renamed. Some cloud resources, they have to be destroyed and they have to be created again. And here we can see what is being destroyed and what is being created. So we have here plus minus. That means there will be both be something that will be destroyed, and that will be something that will be recreated. And then we can see minus. That's what being deleted. Minus, and then we have the same. That is the same. That one right there. And then we have plus, and then we have minus. And yeah, that's it. So that's quite cool. Thank you very much, Terraform, for giving me this overview. Then I press apply, and I say yes. I know one will be destroyed and one will be added. So destroying, creating, and done. That looks cool. Let us go out and see. Refresh. Mike's demo bucket. Quite awesome. Terraform has already been useful. It just changed the name for me, so that's quite good. Oh, that's quite cool. So now let us look at a more advanced example, because there's a lot of people, of course, using AWS. There's also a lot of people using, of course, Asia and all of other clouds, and it is just to look up the provider, and then usually you have to log in with some credentials. This means that I have used the AWS CLI. I've used that to actually create some credentials, which is right now placed in my home folder in the .aws folder. There I have placed my credential file there, where I have an access token and an access token and an access ID, and those are both placed right there. I'll show you the file in just a minute, but let me just tell you that the credentials are actually there. They're just placed on my WSL instance. They are not part of and they should not be part of the Terraform script themselves. You should keep credentials outside of your Terraform files. Here, just for fun, then I've created two files. One, my main.terraform file. This time I have a provider named HashiCorp/AWS. Then there's also a version, because of course a lot of things are happening also on the providers. Every time there's a cloud update, then if there is an update in the API that changes something, then of course the people, the maintainers of the cloud, they also and the maintainers of the provider, of course, they have to be synchronized. So then they have to create a new version right here. So we have the Terraform, we have the providers right there, and then we have the configuration of our provider down here. So this is a provider AWS. I have a region named EU Central 1. That's in Germany, in Frankfurt. Then I have then I would like to create an AWS bucket. And again, I'm not using the naming standard. I don't know why. So it needs to be underscore and not dashes. And here we have a bucket, Mike's demo bucket. And then we can give it some text. The reason why we want to give it some text is just we want to see some metadata in AWS, just because it's fun. So my cool bucket, only for PDF files, that's okay. Environment, integration, purpose. Look what happens right here. So now comes something more advanced. Here we have a variable named purpose. So variable and purpose. Where's a variable declared in? It is declared in the variables.tf file. So the variables are declared in variables.tf files. And here we have the variable purpose, and the type is a string. There are a lot of types here. You can use numbers, you can use objects, you can use lists, of course. So this whole thing right here with the variables, that can be usually there will actually be a lot of variables stored right here. And this is just the declaration of them. So the values themselves then they usually come from outside. They come from a file, maybe. They can also be command line arguments. If they are in a file, then you would usually see something like runtime_values, and the name is just something that I invented, but the important part is the .tf_vars right here, and here you can see here we have a purpose, and that is then the value for that variable right there that I can apply. So tf.tf_vars, that means that this is a value file, and sometimes then you would have multiple value files, maybe one for each environment that you're dealing with, and then you can have different buckets for development, and you can have another bucket for production. And then when I say bucket, of course, it is only your imagination that is the limit right here. You can set up VPCs, you can set up networks in the cloud. You can set up small servers. You can set up all the things. You can actually also define Kubernetes cluster resources. I would recommend you to use Helm instead for doing that, but it is possible with Terraform. And the reason why I prefer Helm is because that the Helm files, they actually look exactly like the kubectl files that can be used directly. So I think it's a bit easier. It's a bit easier to actually create the Helm files than it is to create the Terraform files. But of course, it's only that is a matter of opinion, of course. Kubernetes there's also good support for Kubernetes resources in Terraform. Then we have a file right here named outputs.tf. This is because each of these resources, there can actually be some output, and if you want to direct outputs to a file, then you would usually place that in outputs.tf. So this is the convention. This is a standard. But again, you can choose. You can choose whatever you want to. You can name these files whatever you want. I would recommend you to keep the standard, of course. And I've created one extra file right here. So we have one bucket. That was my AWS bucket right here. And then I've created an extra bucket right here. And again, I'll just use underscore my extra AWS buckets right here. And the name could be Mike's extra buckets. And this could be for the development environment, and this could be for XML files or something like that. And again, we use the purpose from the variable files. Okay, so just to start on a fresh, then I will call destroy, and then I'll delete the Terraform files. Again, I have created this package.json file right here. This means that I can just delete by right-clicking and say run scripts, and then the variable, because we have not, if you do not give any variable file, then you have to fill it out manually on a command line. So that's also a good thing to know. If you have declared defined a variable that is not where you don't have the value defined in any file or on the command line itself, then you have to fill it out. Then the script actually stops and waits for your inputs. Yes. So now we have destroyed it. Let us just delete all the files. Delete and delete. Delete the state file. Delete the backup state file. Yes, delete it. Yeah, okay, that disappeared. So now we have a fresh instance right here. So let us just let me go to my S3 bucket. S3 bucket. Right there. And I have one bucket right there. Let me just delete that. Just so we have a fresh page to start on right there. So I'll just delete that. And go back to my buckets. So now, right now we have 0 buckets right here. And now I want to create my 2 buckets. I have an extra bucket and the original bucket, and this is AWS. So first of all, we need to initialize, just like we did before, Terraform init, and then it starts downloading the provider. It starts downloading the code that will actually be run. That was actually quite fast. The files are right there. then we create a plan, and in this plan right here, we are saying that we are actually mentioning that we have a variable file right here that says runtime values, and this is where the values for the defined variables will be filled out from. This means that we do not have to type them in one by one. Let us just try to run the plan and see what actually happens. Here we say 2 to add, 0 to change, and 0 to destroy. And we can see every time we have a new provider, then we have something that is a little bit different right here. The reason why you see a lot of website configuration whenever you are dealing with buckets, that is because you can actually use a bucket as a website. So that means you can actually add a HTML page and just upload it into a bucket, and then you actually have a HTML page, HTML site. That it is quite awesome. It is quite cool, and it's also a way to actually distribute your. It is a way to distribute your web applications. Yeah, an easy way, I would say. So then we have apply. Let us see what happens. All right. Yes. Thank you very much. It is creating the buckets. Let's go and see if we got the buckets. We got 2 buckets, Mike's demo bucket and Mike's extra bucket. Let me just click one of these buckets right here, because they have some metadata that I would like to see. Properties right here. They have some metadata right here. Purpose, my cool bucket, only for PDF files. Environment, integration, yay. And then we have, I would like to show a demo of Terraform. That is the purpose. Okay, so just for fun, now we will add another apply. First of all, let us delete them. Let's keep them. Let's keep them, because now we just want to change some metadata. Now we do not want to change the name or anything like that, but you just want to change the metadata. This means I'm going to copy this line right here. Apply with alternative metadata or purpose, with alternative purpose right here. So this means instead of having this var file right here, that I can actually say var purpose equal to, and I can make up some other purpose, like something else like this. Let us see what happens now. Now it says that we will not have to destroy any of buckets. We will not have to add any new buckets. We'll just have to change 2 buckets. So this means that it will actually just change the tag to something else, right? So that is quite awesome. Look here, it says I'm going to change the purpose from I would like to show a demo of Terraform to something else. So that is quite awesome. Let us just say yes to that, like this. And then we will go look at our resource. I'll go to my buckets, and I could actually just have refreshed the properties. I'll go to my properties, and then I'll say, whoa, now we have purpose something else. And this is one of the cool things about Terraform. You just say what you want, what the final state should be, and then Terraform will find the whole way forward, because the providers have been, because of course all of this code looks in the providers, and the providers will actually communicate with the API that they need to communicate with. In this situation, it was AWS, it was also Google Cloud, but yeah, all of the big cloud vendors, they actually also have a Terraform provider. It is awesome, it's very interesting. Please try it out. I hope you liked this video. If you did, then please like, subscribe, and hit that notification bell, because we have a lot of cool stuff coming up. Bye.